Welcome back to the ProCaaSo tutorial series. Today, we're going to be diving into how to effectively test our newly added I/O code using tools like Syndi and the ProCaaSo VS Code extension. You will learn how to understand the basics of utilizing Syndi for remote tunneling tasks and learn to leverage the ProCaaSo extension for debugging your code directly within VS Code. Syndi is the ProCaaSo CLI pivotal for remotely tunneling tasks to your systems. This allows for debugging and testing functionality across your network. Syndi also packages your code for the ProCaaSo framework, but we'll focus on that capability in a future video. Remote tunneling is a game changer, allowing us to debug our systems from anywhere. By setting up tunnels, we can directly interact with the edge devices our systems are connected to, all from within our development environment. To simplify the tunneling process, we utilize ProCaaSo Extension and VS Code. Here's how to get started. Open VS Code and trigger the command palette with Ctrl, Shift, and P. Search for ProCaaSo to see all related commands. Initiate your workspace setup by selecting ProCaaSo Configure New Environment and enter the URL of the environment you're working with. After these steps, a notification confirms that your environment is configured. Next, authenticate your session by using the auth login command and log in through the provided URL. The terminal will indicate if you have successfully authenticated your account. Confirm your identity in ProCaaSo by checking your credentials with the auth whoami command. Now that we have everything set up, we can start tunneling into our edge device. There are two ways we can open a tunnel and receive direct feedback from our hardware. If the hardware is local to you, you may connect the edge device via Ethernet and debug with the I/O map that we defined in video 4. If the hardware is elsewhere, we are able to adjust the I/O map to communicate with the edge device by port forwarding to redirect communication requests from your development device to the edge computer. Please select your situation to jump to the tutorial or watch both. Opening a tunnel via Ethernet connection. Start by ensuring that there's an active Ethernet connection between your development device and the edge device. This physical link is the lifeline for your tunnel, providing the direct pathway needed for the data exchange. Open the command palette in VS Code with Ctrl, Shift, and P, and type in ProCaaSo Start Development Tunnel and hit Enter. This will initiate the tunneling process through the ProCaaSo extension, which is designed to simplify and streamline the setup. Once the command is activated, you'll be prompted to select the environment that you've previously configured. Choosing the right environment is crucial. It ensures that the tunnel connects to the exact device configurations that you've prepared. Now, select the trial site follow-along system from the options available. This tells the extension exactly which system within your environment to link to. After you make your selection, the tunnel will open automatically. Look for a tunnel status indicator in the bottom right corner of your VS Code interface to confirm everything is operational. To close the tunnel, simply click on the Tunnel Status tab and it will disconnect. If you need more information on your active tunnel, head over to the Output tab in your terminal. Select Syndi Output to view details on open tunnels and ports. This is also where you can check for any debug statements if there's an issue with a tunnel opening. And that's it. You've successfully opened a tunnel via Ethernet connection. If you're ready to move on and would rather skip the section on port forwarding, feel free to jump ahead to our debugging process tutorial. Opening a tunnel via port forwarding. The steps will be a little different as it is a new feature and hasn't been integrated in our ProCaaSo extension yet. We'll handle this setup manually. Let's begin by adjusting our I/O map to facilitate port forwarding. We'll change the unique ID and address from the actual IP address to localhost. This adjustment enables our development system to route commands directly from the IP address of the edge device. Next, we need to assign port numbers that will direct the communication. For the distance sensor and stepper, we'll use port 8000, which is consistent with the port used by the API server running on this device. For the environmental sensor, we've chosen port 4042, an arbitrary selection suitable for our setup. This integration enables you to control and debug the physical hardware directly. Don't forget to update your new I/O map in ProCaaSo. Now, since the ProCaaSo extension doesn't currently support port forwarding tunneling, we will proceed manually. In VS Code, you can open a new terminal with Control, Shift, and tilde. Type the following command in your terminal: Syndi tunnel, which is the command to initiate the tunnel, the system ID, which can be retrieved from the URL from the systems page in your ProCaaSo environment, and then the first destination argument is to access the ProCaaSo framework, and the next two destinations are specific to our physical hardware. So, we use the destination call, then feed in the port number that we defined in the updated I/O map, along with the IP address of the hardware and the communication port, which will be 44818, which is the standard port number for Ethernet communications. Similarly, we do the same thing for our distance sensor and stepper. We use the destination call and feed in the port we define in the I/O map, as well as the actual IP address of the communication device, and then the communication port for the fidget is again 8000 since there's an API server open on that host. Then lastly, we define the environment that we want to communicate with, and we do this by using the -p flag and following it with the name of our environment. Once everything is set, hit enter to open the tunnel. This action establishes a communication channel to your edge devices, effectively linking your development environment to the physical hardware. Now that we have an open tunnel, we are able to remotely debug our code. First up, let's launch the debugger in VS Code. Navigate to the debugger icon on the left side tab to open the debugging panel. From there, select Run ENS.py under Task IO2 and hit the play button. This will start the debugging process for all the code within the IO2 folder, giving us real-time feedback as debug statements flow into the terminal. As we watch the outputs, let's pause the debugger by clicking the stop button. This is where we can gain a deeper understanding of what's happening at specific points in our code by setting breakpoints. Let's add a couple. Place one on line 27 and another on line 50 in our ENS.py file. Once set, restart the debugger to see them in action. You'll notice that the debugger will pause on line 27. Now we can further examine the code from here. Let's click on the Step Over button on the debugger. Step Over is particularly useful when you're not interested in debugging the internal workings of a called function or method, but instead want to focus on the higher level flow of the current function. In this case, we just want to verify whether we've successfully retrieved the I/O map from the ProCaaSo framework, so we can go ahead and use this and see if it logs out the I/O map definition in the terminal. This step is key to verify if we've successfully retrieved the I/O map from the ProCaaSo framework. Once confirmed, press Continue to let the debugger proceed to the next breakpoint unless it encounters issues along the way. If a deeper inspection of functions is needed, use the Step Into button. This will take us directly to the env iologic.py file where a logic for the environmental sensor is defined. To keep our focus on the higher level flow of our function, use the Step Out button to exit the current function and return to the ens.py file. Now, let's delve back into the env user logic function and run it line by using the Step Over button. Start by confirming that the data from the event bus syncs up with our Python data models. Next, ensure that we can indeed communicate with our Moxa. Step over the next few lines to check if we can read values from the Moxa device. It looks like we were able to successfully pull values from the Moxa device. Now let's convert the raw values using the conversion functions from the IO logic class and print the values to verify that they match the physical hardware. Great! It looks like we are able to convert the raw sensor values into current. Let's now convert the current values to humidity and temperature. It looks like we logged out a value of 0% for the humidity, and we have a temperature of 25.3 degrees Celsius. Let's look back at our dictionary of values that we retrieved from our Moxa. It's evident that there are values being read from the sensor, but let's verify that we're referencing the correct index. Alright, so let's go ahead and start 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It seems that we have mistyped the index for the humidity sensor. Let's go ahead and update the incorrect index value to the correct one. So we'll go ahead and change the index from 16 to 17 for our humidity current. Now, we can notice that the updated index value yields the correct value from the sensor. Thanks for joining today's debugging session. You've just navigated a thorough debugging process using VS Code, enhancing your understanding of how to manage and troubleshoot your applications within the ProCaaSo environment. Be sure to catch our next tutorial where we'll explore the app task. Happy debugging and see you next time.